Today we're going to talk about identifying and graphing polar equations. So in this first example I have r equals 3. So we know this is in polar because it gives us a radius. So what I need to do to graph these is always change them to rectangular coordinates, and then you graph them on a polar plane, but it's in a rectangular coordinate that we understand. So since r equals 3 here, again what I want to do is convert from polar to rectangular. So what I'm going to do is square both sides. And the reason I square both sides is because I know that r squared equals x squared plus y squared. So now that I have r squared, I can change it to x squared plus y squared equals 9. And the reason I want to change it to x squared and y squared is because, again, rectangular is in x and y. So that means my goal for these is to try to change everything into x and y. So again, I squared both sides so I could get r squared. R squared equals x squared plus y squared, and that equals 9. And I recognize that that is a circle with a radius of 3. So I've identified that graph. Let's do another one. Here we have theta equals pi over 4. If theta equals pi over 4, again what I want to do is change everything into y's and x's. Well, I know that the tangent of theta is equal to y over x. So what I'm going to do is multiply by tangent on both sides. So I take tangent of theta here, and so of course I have to take the tangent of pi over 4. Well, again, the tangent of theta is y over x, and the tangent of pi over 4, if you look on your unit circle, is 1. So now that I have y over x equals 1, what I'm going to do is multiply both sides by x, so I can get y by itself. So if I multiply both sides by x, I get y equals x. And that turns out to be a line straight through the pole at pi over 4. And the reason, let me zoom out a little bit, at pi over 4. The reason it's at pi over 4 is because my angle was at pi over 4. So if I were to graph this, it would look like this graph here. It's going to be a straight line, and it's going to go through pi over 4 right here. So if this is my unit circle, this is pi over 6, and this is pi over 4. I got a straight line through that. And I know y equals x is a straight line because if I graph it on my graphing calculator here, I go to y equals and I type in x, I know it's a straight line. So I know that straight line is going to go through pi over 4 because I had theta equals pi over 4. So again, our goal is to always turn these into x's and y's. Do another one here. We have r sine theta equals 2. Well, r sine theta, if you remember, is equal to y. So I can automatically change that r sine theta to y, and I get y equals 2. Well, y equals 2 is a horizontal line, and it's going to be 2 units above the pole. So again, if I were to graph it, this is my pole here. I'm 2 units above right here, and there's my horizontal line. I did that because r sine theta equals y. So it's handy to know what all the conversions are from polar to rectangular coordinates. Alright, here we have r equals 4 sine theta. If r equals 4 sine theta, again our goal is to get x's and y's, which means I need to get it in a form I recognize that's a polar form. So we know that r sine theta, r cosine theta, and tangent theta are all things that we can change into x's and y's. So I have to try to get this to look like r sine theta. And how I'm going to do that is multiply both sides by r. So r times r is r squared, and 4 sine theta times r is 4r sine theta. Well, now I have that r sine theta that I can change to a y, because r sine theta equals y, and r squared we know is equal to x squared plus y squared. So I can change it from x squared plus y squared, or into x squared plus y squared, and then r sine theta changes into 4y. Now if you look at your flowchart here, I can identify that this conic right away is a circle. And the reason I know that is because this is an x squared and a y squared, and they're multiplied by the same number out front, so this is a circle. However, if I wanted to know more information about the circle, I would just do everything I did before by moving the 4y over, completing the square on the y's and the x's, doing all of this factoring, and then I end up with a circle that has a radius of 2 with the center at 0, 2. Now again, I don't have to go this far unless the directions ask me to give me information about the conic section. If I know from this step right here that x squared plus y squared equals 4y, if I know that's a circle, then I can stop right there and say that it's a circle. But if it asks for more information, then I need to do all these steps like we did when we studied conic sections to get a circle with a radius of 2 and a center at 0, 2. So again, what I had to do was get my polar coordinates into something I recognized that I could change into rectangular. So what I did was multiply both sides by r here, and then change it. Alright, we'll do a couple more. Here we have r equals 8 over r plus 8 cosine theta. And what I'm going to do, since I have a fraction, is multiply by the denominator to get rid of that fraction. If I do that, I'll have r times 3 plus 8 cosine theta equals 8. So then what I did here was distribute this r through so that I get 3r plus 8r cosine theta equals 8. That's where that step comes from. So then what I can do is change this r to the square root of x squared plus y squared. The reason it's the square root is because r squared equals x squared plus y squared. So if I have just r, then it's going to be the square root of x squared plus y squared. Plus 8, we know r cosine theta is x. So I change that to an x. And that's how I get that step there. And then from there, what I'm going to do, I want to get rid of this square root now. In order to get rid of this square root, I need to get this whole thing by itself. So I have to move this 8x over. So that's what I did right here, is I subtracted the 8x. And now to get rid of the square root, I'm going to square both sides. So here, if I have 3, and then I get rid of the square root, I have x squared plus y squared here, and that 3 is squared also, equals 8 minus 8x squared. Well, 3 squared is 9, and then I have to distribute that 9 onto both of these, so that's where I get 9x squared and 9y squared over here. Equals, what I'd have to do here is write this binomial out twice, and then distribute. After you do that, you get this equation right here, which is 64 minus 128x plus 64x squared. Again, all I would do here is distribute all of this. Then what I do, since I have a 9x squared here and a 64x squared here, I'm going to combine my like terms, so I subtract the 64x over. If I subtract that 64x squared, I get negative 55x squared plus the 9y squared equals 64 minus 128x. And now I stop here because I see right away that I have a negative x squared and a positive y squared. And according to our flow chart, if our terms are squared but have opposite signs here, then we have a hyperbola. So again, what I had to do was get rid of this fraction here and then change all my r's into x squareds and y squareds, or just x's. We'll do one more. Here we have r equals 1 over 1 minus cosine theta. Oh, there you go. So again, what I have to do to get rid of that fraction is multiply both sides by the bottom and then distribute my r. So I get r minus r cosine theta equals 1. I know r is equal to the square root of x squared plus y squared. R cosine theta is x. So I just have the square root of x squared plus y squared minus x equals 1. And then to get that x squared plus y squared by itself, I add that x over. And then I square both sides. And again, and when I square this, I have to write the binomial out twice. So I end up with this. And then I combine my like terms by moving that x squared over. So if I move this x squared over here, I get y squared equals 1 plus 2x, which is a parabola. And that's how you can identify polar equations.